And we're also going to add the graph of tan. So if we think about going around our unit circle and our axes family for tan, and we label 2 pi and split it into our 4 quadrants there, pi over 2 pi, 3 pi over 2, we know that at 0 pi and 2 pi, tan is 0. So we get these points to begin with. But because tan is undefined at pi over 2 and 3 pi over 2, that shows up on the graph as vertical asymptotes for non-permissible values. And so we have these vertical asymptotes, and this is what the graph of tan looks like. It looks actually like a bunch of x cubed graphs stuck together. Now if we go to your textbook for some highlighting stuff, the graph of tan has a period of pi. So that's one difference between the graphs in sine and cosine and the graphs of tan. It repeats itself from one asymptote to another asymptote. So from pi over 2 to pi over 2 to 3 pi over 2, this distance here is pi, and that's its period. Again, you could also start from 0 and say, when is the next time it gets to 0? That distance is pi. And so it repeats itself over a smaller distance, and we have a bunch of asymptotes. In fact, if you think about asymptotes happening at non-permissible values, and one of our big ideas is that tan is sine over cos, we know we can't divide by 0, so our asymptotes are exactly at the same place where cos is equal to 0. So our equations of our asymptotes, and the way that they're written here, and its domain, we're going to write it in the proper way. The way that they wrote it here, where n is an odd integer, we're going to write it in the more proper way using the zeros of cosine. So first of all, off to the side, all of the asymptotes can be written like this. Vertical asymptotes are always x equals, and you can write it as 2k plus 1 times pi over 2, where k is an integer. And that's the same way that we wrote the x-intercepts for cosine. Remember, in cosine, we wrote it in 2 different forms. You could choose here as well. You could also write this whichever one you feel makes more sense to you. I actually like the pi over 2 plus k pi. Since the period is pi, you start with one asymptote, and then you get to jump to the next asymptote by adding or subtracting pi as many times as you want. So either of those are fine for the asymptotes. The result then is, for your domain, you can choose either one of those and just go x can't equal pi over 2 plus k pi if you chose the second one. And when we write our domain and there's non-permissible values, that's when we put the line through the equal sign to say x can't equal. Equations of asymptotes are always x equals because they're an equation. But for your domain, when you want to exclude values, you can say x can't equal those values. The zeros. You may notice that the zeros are always multiples of pi, and that the zeros are equal to the zeros of sine. In fact, if you think of it as sine over cos, the only time a fraction is equal to 0 is if the numerator is equal to 0. Denominator can never equal 0, and the only time a fraction is equal to 0 is if your numerator is equal to 0. So the zeros of tangent are exactly the same as your zeros of sine. Function has no amplitude, it has no minimum or maximum value, and the range is everything. So when we go to example 2, just erase this. Perfect. Each of these ones asked us to determine the period. Again, we're going to determine the period and we're going to graph them. So if you're thinking about y equals cos 6x and you're wanting to graph it, well, we've got a 6 here. And that 6, can you see that it's inside your function? So this is going to be a horizontal compression because you would multiply x by, remember the reciprocal, 1/6. So what does that mean for our graph? Well, when we would graph our cosine graph normally, we would label our amplitude. In this case, since there's a 1 in front, our amplitude's still going to be 1 and -1. And then we would label our period. And our period was normally 2 pi. But now we've had a horizontal compression by a factor of 1/6. So instead of our period being 2 pi, we're going to have to multiply that 2 pi by 1/6. And we're going to get a period of 2 pi over 6. And normally we would then split this into 4 equal sections. But now we have to label those 4 equal sections with new values. Now when I'm labeling these 4 different sections, and I know my period is 2 pi over 6, I always start with half. If you take 2 pi over 6 and cut it in half, does it make sense you'd have pi over 6? And then if you took pi over 6 and cut it in half, or multiplied it by 1/2, you would get pi over 12. So I find the middle one first, then I find the smaller section, and then since each of these sections are equal in size, I take the fact that one section's pi over 12 and I just count. This would be 1 pi over 12, 2 pi over 12, 3 pi over 12. You don't need to reduce those, but you could. If you wanted to write 3 pi over 12 as pi over 4, and if you wanted to write 2 pi over 6 as pi over 3, you could, but you don't have to reduce those. And the way that I figured out that 3 pi over 12 was just by counting. If this is 1 pi over 12, this is 2 pi over 12, and then this would be 3 pi over 12. And this one would be 4 pi over 12 if you'd like. So now to draw my cos graph, first of all, our cos graph always starts at a maximum. So there's my maximum value, then to the center line, down to your minimum, back to your center line, back to your maximum. Draw your smooth curve, going through all of those. And here, our period is 2 pi over 6, or pi over 3. Second one, we've got tan of 2/3 x. Horizontal stretch or horizontal compression? It'll be a stretch because we would multiply our x values by the reciprocal, which is 3/2. Now, when going to graph your tangent graph, I always start with my asymptotes. And so I have an asymptote here and an asymptote here. And they started at pi over 2 and negative pi over 2. But if I took pi over 2 and all my x values are getting multiplied by 3/2, my asymptote is going to change, and it's now going to be at 3 pi over 4. And this one over here at negative pi over 2 will now be at negative 3 pi over 4. The shape of our tan graph still will stay the same. It'll look like a bunch of x cubed graphs repeating itself. Our period was pi, but now our period is from negative 3 pi over 4 to 3 pi over 4. Again, notice that all that's happened is that your period, which was pi, gets multiplied by 3 over 2, because that's what the horizontal stretch would do. If you had a period of pi and you're multiplying your x values by 3 over 2, your period will become 3 pi over 2. And finally, part C, we want to look at y equals x over 7. Sorry, so y equals sine of x over 7. Are you okay if I change x divided by 7 to 1/7 x? Because dividing by 7 is the same as multiplying by 1/7. And when we write it that way, we see that that 1/7 is inside. It's going to be a horizontal stretch. You're going to multiply all your x values by 7. So when I go to graph this, well, sine still has a maximum of 1 and a minimum of -1. My period normally is 2 pi. But now that I've stretched it by a factor of 7, when I multiply 2 pi by 7, I'm going to get 14 pi. And dividing this into 4 equal sections, again, I would start with this one. Half of 14 is 7. Half of 7, you can either write it as 3.5 or 7 over 2. And the third one will be 1 7 over 2, 2 7 over 2, 3 7 over 2s, which will be 21 pi over 2. Where does the sine graph start? The sine graph starts in the middle going up. So we go from middle to maximum to middle to minimum to middle. And so we get that our period is 14 pi. Now at the bottom of the page here, there's a little thing that says the period for trig functions. What I would like you to write is there are 2 formulas for both sine and cos and 2 formulas for tan that are useful. These formulas are not on your formula sheet. But anytime you have sine bx or cos bx, you have a horizontal stretch or compression, which means that you multiply by the reciprocal. So that means if your period was 2 pi, when you multiply by the reciprocal, which is 1 over b, your period becomes 2 pi over b. And if you take this formula and rearranged it to get b by itself, you would get b is equal to 2 pi over your period. Same thing with tan. The period of tan starts out as pi. So if you have a horizontal stretch or compression, you would multiply by 1 over b. So now your period for tan is always going to be pi over your b value. And rearranging that to solve for b, your b value in a tan graph is always pi over your period. Okay, you can do the rest of C now. I mean the rest of 3, C and D.